Hello, friends. Welcome to Life and More. India's space journey, especially during the last 10 years, has been an inspiring one. And, uh, and it is inspiring a new generation, not just to watch the missions, but to build them. And a similar thing, the students of Thapar Institute of Engineering and Technology, Patiala, they have done. Now they are building their own satellite titled ThaparSat. Today we have Dr. Mamta Gulati with us. She's the project coordinator of the program, and she'll tell us more about ThaparSat and the technological advancements and the environment of the day. Welcome, Dr. Gulati.
Yeah, thank you so much. Thank you so much, Miss Rajkumari. It's a pleasure being on the podcast with Life and More uh,
Yeah,
with you. And
yeah,
thanks
my
for
pleasure.
giving us well, thanks for giving us the opportunity to talk about the student satellite program that we
Yeah,
have. It's To introduce myself. I'm Dr. Mamta Gulati, and working as a professor in the Department of Mathematics at Thapar Institute of Engineering and Technology. And Currently, I'm the coordinator of the satellite program. And
yeah,
I finished my PhD back in 2014 from Indian Institute of Science, Bangalore, and Raman Research
okay.
Institute, Bangalore. I was a joint student of both the institutes. And
Mm,
My specialization begins from astrophysics, I mean, to be precise, working on galaxies and galactic dynamics. And From there on, we moved on to learn about the radiative transfers, how the radiations transfer travel into a medium. From there, we learned about the remote sensing technologies and satellite development and all these things. We had a chance to learn from some of the experts during our PhD days also. And that's
yeah,
something about my background related to the field. Uh, Coming to the student satellite program at Thapar and the initiative taken by TIT, this
yeah,
program started back in 2019 is when we
okay.
started talking about venturing into the space domain. And the first
Mm,
thing that came into our mind was that what are the key space technologies that we can adopt, which are mostly interdisciplinary. So that
mm,
gave us uh, uh, a trigger point to start looking for what all we can do. And the first thing that came into picture and started realizing is we started realizing realization of the same is that let's start building a small satellite which has a lot of interdisciplinary components,
mm,
which can include students from all the branches of engineering, all the way from computer science to electronics to mechanical to chemical to civil. I'll tell how
mm,
all these branches are involved in the satellite development in a while. But this was one
mm,
project where interdisciplinary research was the core component that we started with, and
mm,
that's how we began the journey in 2019.
okay.
And The very next question, after we decided that now we want to venture into the domain where we want to build satellite, was that which satellite or what kind of satellite and what it will do,
Mm, mm,
because you can't be sending anything to space which has no purpose. It has to
yeah.
has its own objective and purpose, which it will
Mm,
solve. So, being in northern India, we started looking at the issues which
mm,
North India was facing at that time, and one of the issue
mm,
that came popped up was pollution monitoring, and there was no such dedicated system. I'm not saying no such system is available, but this is something that needs also a regular monitoring pollution in at any place to begin with. We are in Punjab, so we started with North India, and So we said that okay, we'll start with the first objective as a pollution monitoring satellite. So that's what
Mm,
we call ThaparSat as. It's a real-time pollution monitoring satellite that we
okay.
have we have been working on. And then the next obvious question was, how do we do that pollution monitoring using this satellite? Now, since the
Mm,
first tagline was decided, then we thought that how, what, I mean, first was first what, then was second what, and then now we started looking at the question of how. And
mm,
that's where various experts from ISRO and industry, we discussed with them, we started collaborating with them, and we came up with the idea of what kind of payload should go into the satellite, which will enable the pollution monitoring. And so we started with that discussion, and we ended up having decided that we'll go with the infrared camera, which will do the measurement of greenhouse gases. So that's the question answer to the question how, that we will do the pollution monitoring using the infrared radiation and measure the absorption spectra of greenhouse gases. So that's how we will do the measurement. And that's where the objective was decided. And that's where we then moved on to the formal technical development of the system. And that started in 2020, where we had roped in one of the industry partners also with us, which is Data Patterns in Chennai. And we then started developing the various modules and things like that. We developed we have our own ground station to begin with.
in
We can
Patiala?
discuss. Yes. So
Okay.
the satellite monitoring and control station is developed in Patiala at TIT campus. So we will be
Okay.
controlling our satellite, downloading the data from here, and we also will be sharing the data with the Punjab government
Mm,
bodies to actually
mm,
use it for their, I mean, aid the policy making
mm,
process
mm,
that
mm.
they already have in place.
So,
That's
okay. So
the background and broad picture. Yeah.
what exactly, which state are you at now with ThaparSat? Where are you placed? Like how much work is done
So
and how much is left?
the yeah, so for any satellite, the first thing is
Mm,
of course the objective, and then how do you want to do it? Then you have two.
mm,
We ourselves divided our project into two components. One was the
okay.
development of ground station that we have, and the other one was the development
Mm,
of the satellite bus. Because you can develop a satellite bus, but you
mm,
need a ground station to observe it. You
mm.
have a ground station, but what do you do with it? You need a satellite. So these two things
Mm.
have to go parallelly as far as the
Simultaneously.
engineering aspect of any space mission is concerned. So we started on both
Okay.
these simultaneously. So the ground station that we have has a capacity of doing observation in three bands: UHF, VHF,
Mm,
and S band frequencies,
okay.
and
Okay.
it's fully functional since 2022, just 2 years after we formally started the assembly
Mm,
and the design part of the components.
okay.
So from
Mm,
2022, the ground station is it's fully operational, and
operational.
we do
Okay.
yeah, and we also do quite good amount of observation from the open source satellites, which are weather monitoring satellites, which gives our
Okay.
student a, a training ahead of the launch of our own satellite, that how live
Mm,
data is recorded, how image processing is done, and
mm,
how do you, and I mean, once your image is ready, what all you can take out from that image. That, for example, we take pictures for a satellite called NOAA satellite, which is a US weather
mm,
monitoring open source satellite. So that has
okay.
two different kind of images that it gives. One is the weather map,
Mm,
the cloud cover
mm,
map, and one is the temperature map of the ground. So
okay.
if you have the cloud cover and there is a cyclone that
Mm,
is developed, I'll just give an example to understand that what kind of uh, processes can
Workforce.
be started, or the students here
Mm,
have been working on from here. That's
mhm,
just one example. So you have a
mhm,
cloud cover and you have a cyclone that is developed. Now that
mm,
cyclone moves the way in the wind, in the direction, or in a pattern where the wind patterns will take. And one of
mm,
the key component of the wind patterns is the
mm,
temperature gradient of the ground, how the
mm,
temperature
mm,
variation at the ground is happening. So
mm,
we did the observation for the cloud cover, we did the observation for the temperature map, and we then correlated that how one cyclone will be moving ahead. So this was live data that was recorded, and then a prediction modeling was done to predict the direction of the cyclone motion. So that's something that that's one project, one of the projects that our student did in initial days. Then they were also
mhm,
involved in development of the ground station at all the stages, starting
mm,
from the what kind of antenna should be there, to
mm,
assembly of the antenna, to setting up the software systems of the softwares of observations and everything. Now that's the ground segment that we have. It's operational. It's called Thapar Satellite Control and Monitoring Station. It's located at the Patiala campus of Thapar. And next, once this was ready, then we started the fabrication and the assembly of the satellite components. And we started with the OBC, then the battery modules, all the thermal. There are a lot of modules that are there. There was payload and all these things. And 2024 is when we finished all the assembly and individual component tests of the
okay.
satellite. And then the full
Mm,
satellite was ready for the complete testing. Then we went on
okay.
with the testing phase of the payload, which is also now
Mm,
completed. Now, what we are doing is we are doing the final integration, and the final testing is in progress. And
mm,
we are looking forward for the satellite launch very soon,
mm,
probably
okay.
in the
Any,
we don't have the
uh,
dates yet, so we
okay.
are in discussion with the InSpace, which is the regulatory body for government of India, for the launch of the
Mhm,
satellite. So you'll get that
mhm,
announcement pretty soon. I
mhm.
that's
Yeah,
that's
yeah.
the idea. Yeah.
Okay. So ThaparSat is like, particularly you said that it's monitoring pollution, the greenhouse gases such as carbon dioxide and methane. So is it, will it only be limited to that, or it can do some other
No,
broader works? And also, how much, like, you'll monitor that this is the greenhouse gases, and this is the extent of gases
yeah,
in the
I'll,
environment. But what from there? Are you, will you also be suggesting some, like, solutions to reduce the greenhouse gases?
Yeah, I'll take that. I'll answer your question in two steps. One is
Mhm,
that once you have the greenhouse gases measurements, so for greenhouse
mhm,
gases measurement, we are not just targeting carbon dioxide and methane, we are also targeting nitrous
mhm.
oxide and water molecules, because
Okay.
they also affect the environment a lot. And these
Mm,
gases were chosen so that we can single out the the source also of various kind of pollution, like if it is an industrial pollution or an agricultural waste pollution, or due to water bodies or traffic, so to say. So
mhm,
the various gases will tell us what is the source of
mhm,
the that pollution. So once you know what
mhm.
is, you can pinpoint the source of the pollution. You can always like go back and have the policy in place to like
So that's where the
monitor it.
government will come into picture. That's where the government will
Exactly.
come into picture.
Yes. Yes.
Okay.
Because there has to be a the some enforcing agency. That's where
Yeah.
we
Mm,
discussed with the Punjab government to take up the
mm.
role of like using the available information and for using it for
Okay.
their. It's not
And
that they're not. And
how
I'll tell
open
you
were
about
they to this?
Absolutely very open. They have been in contact,
Okay.
regular touch with us, the pollution department
Mm,
and the DST wing
mm,
of the Punjab DST wing. They have been in regular touch with us. They are waiting for the
mm.
launch to happen and
Okay.
uh,
Okay.
to collaborate on further on this. I'll add to what
Mm.
other applications ThaparSat will do. For
Ah,
example, we have
yeah.
targeted methane. So
Okay.
methane leakages can happen through LPG pipelines, which we will be
Mm,
able to monitor. So that is one more
mm,
use, not just pollution, but it also helps us in avoiding. If we are able to do an early detection of methane leakage, it helps a
mm,
lot of accidents that can happen.
mm, mm,
It can help
mm.
us avoid those accidents.
Okay.
Then
Mm.
we also have, like, for example, during the puddling season of rice, if the puddling,
Okay.
water puddling is
Mm,
done to an extent which is more than the critical level,
mm,
there's a lot of methane
mm.
that will be released from there, which affects the
Okay.
health of the farmers, to say
Mm,
a lot.
mm.
So, because
Mm.
methane is one gas which goes undetected unless and until you start seeing its effects on your own body. It
Okay.
doesn't have smell, it doesn't burn. So, most of
Mm,
the ways in which you detect these gases on a preliminary basis, methane does not
mm.
it doesn't react to that. So,
Okay.
if we are able to tell from our measurements that okay, there is
Mm,
excessive, there's a methane increase happening in this region, and probably an
mm, mm,
excessive puddling is done. So, a farmer's
mm,
health, which would have affected because of this,
mm.
can actually be monitored and kept a check on it. So these are some
Okay.
of the things that will
Mm,
be of a societal benefit of these
mm,
measurements. We'll also
mm.
be able to tell about the soil moisture content from the water measurements that we have. So these are
Okay.
some application oriented
Ah,
objectives of this
ah.
from the same measurement that we will
Yeah.
be doing.
Yeah.
Yeah.
Yeah. Yeah. So while building this satellite, what has been your like biggest challenge? A scientific challenge
Uh,
or an engineering challenge or simply getting students from different fields, like you said that there are students from all streams of engineering into it. So what
yes.
was your biggest challenge?
Biggest challenge is something that there are two things that I
Mm,
would like to point out, but they're not challenges. But
mm,
these were something that we had we had to put in a little extra effort to get a resolution for the same. The
okay.
first one was that we are in the middle of the city and we want to put a
Mm,
ground station there. There were a lot of interferences that were happening because of all
mm,
the radio communication in and around in the city. So, putting
mm,
up a ground station here, which
mm,
has a good resolution of measurement and good signal to noise ratio, was
mm.
something that we took it up as a challenge, and we are happy that
Okay.
we have been able to successfully do it. Hats off to our
Mm,
students who have worked day and night on that. So
mm,
we could do it on. I mean, the operational part is like as per the norms of any standard ground station. So that was
okay.
one challenge that we faced. And I'll come to
Mm,
the question how the students helped in it. And the
mm,
second challenge was because we were working with hazardous
mm,
gases like methane and nitrous oxide and CO2. The testing the payload that we have developed on ground
mm,
in lab, that we had a
mm,
threat, we did radiative transfer modeling to actually
mm,
develop the payload. We then fabricated it. Now the next part was that we are claiming something from a model. How do you test
mm,
it practically? Whether your model is
mm.
working or you need a fine tuning of it.
Yeah.
So testing that phenomena in lab with these gases, for example, we tested with
Mm,
CO2 and methane, and the
mm,
results are there on as research publications. on open source platforms. It can be searched always.
mm,
And so
mm,
testing that part was also a
mm,
challenge because the test that we developed was not purchased
mm.
from the market. Starting from
Okay.
a pneumatic fitting to a full gas chamber which will handle these hazardous gases and mimic the space atmosphere. So you have to imagine that you are in lab and now you have to mimic
Mm,
an atmosphere which is of 5 kilometers of height, right?
mm,
So that was a challenge, and our
mm,
students took that challenge up, and we did a very good, successful test. And the efficiency measurement is we got a 95% efficiency measurement efficiency that we have, and it's as per all the technical specification that were given for the camera when we purchased it. So these were two main challenges where we
mm,
had a challenge from a technology point of view also, where we have a
mm.
challenge sometimes from our geographical location point of view also. And
Yeah.
so yeah, the students took it up very positively. For example, when we were building ground station, the ground station was
Mhm,
developed at the in a building which was of I mean, the highest building in the vicinity, in the
okay.
campus, the highest building, because you need your antenna to be looking at the sky all time. You can't have
Mhm.
obstructions. So it was to
Yeah.
be put at the highest building, which is
Mhm,
already being built, and putting up an antenna which will be of like weight of about 100 kg,
mhm,
and making a very stable structure that it will
mhm,
withstand all the wind loads also
mhm,
was some challenge. So the students had to do the structural analysis of the whole building again and say that this much load will be acceptable, this is the vibrational load will be there, and how do you install it and all these things. So this is one of the challenge which, for example, the mechanical engineering students took up,
mhm,
analysis
mhm,
of the structural load.
mhm,
The analysis of how do we do that greenhouse gas measurement, measuring the
mhm,
absorption spectra and everything, the chemical engineering students were involved in it. And the antenna testing and all these component testing, the electronics testing and electronics development, or the design of that, the electronics engineering students were involved in it. The image processing part or the modeling part that we have, all the computer science students participated in it. So, and of course, there were cross matching also. So, some of the
mhm.
computer science students that we have started working on the antenna testing as well. And we had
Okay.
a person from civil engineering who also started
Mm,
working on the orbit calculation for satellite that we had. So,
okay.
we did calculate how our satellite will move in the orbit. So, there were cross breeding as well, but
Yeah.
mostly the problems were specific to their branch that they picked up.
Mm, mm. How
Yeah.
big is your team?
Um, at any given point, we have about 30
Mm,
students from various engineering departments working, and we are a team
okay.
of 6 faculty members that are working
Mm,
from various different domain. We have
right.
faculty from computer science, electronics,
Mm,
mechanical, and myself being an expert on remote sensing and astrophysics is there in the team.
mm,
And
mm,
at any given time, we have about 30 to 40 students working on different research projects. We do have PhD students also working on the project. So the engineering students, they kind of take up the project either in their second year or third year, and so
okay.
we induct them in the beginning of their second year. Okay,
But
so
that's
they
quite
work
a
for
young age.
one.
That means an
Yes,
18 or a 19-year-old child.
absolutely right. So they are very enthusiastic, and
Mm,
the kids are sharp. They learn very
mm,
fast. They pick up
mm,
things very fast, and they have been
mm,
like I mean, working with these young chaps have been an asset,
mm,
as that I will say that it's one of the most pleasant experience that I had
mm,
during the journey. So That way, I
Okay.
mean, it's a very nice experience. We say that there is a kid, what
Mm.
will he do? We need a senior scientist always.
Yeah.
No, that's not the case.
Mm.
Many a time they will come with a solution which we don't think of it because they are young,
Mm.
their mind is fresh and they can think out of the box. That's
Yeah.
something
Yeah.
that
Yeah.
helps, and
Uh,
especially in
and
space
how much of
technology because especially in
tell
space
tell.
technology because
Mm.
that's what they have been seeing this from last 10 years all across the media. 10 15
Mm.
years the space technology has picked up in India on a public
Mm.
scenario also because
Mm.
there are a lot
Mm.
of new launches that ISRO is being doing, and there are a lot of ventures, lot of startups that are coming up. So these guys, and not just India, even like SpaceX, it's
Mm.
all over the
Mm.
internet, and people read about it.
Mm.
Now we have Skyroutes with us, which is
Yeah.
now all over internet for
Mm.
their successful launch. So these people
Mm.
are reading about it in and out every time, and they are very
Mm.
enthusiastic. They already have seen things happening,
Mm.
and when they see things happening, what they do, the first thing is that they go back and read about how these things are happening on their own.
Mm.
And
Mm.
so they were already motivated to look into
Mm.
space technology. So I think I can claim that space technology in
Mm.
future, maybe or not, it's one of the will be one of the key favorites, like AI
Mm.
has been for last 10 years for the students,
Yeah.
because it's
Yeah.
actually picking up. It's
It's
actually gaining
actually
a lot
picking
of
up.
interest for the
Yeah.
students.
Yeah. Yeah. And I'll come back to you. You come from a mathematics background. And
Yeah.
how much of maths goes into like converting like
Um,
raw satellite data into meaningful scientific information that like you are a
yes. Okay.
mathematician, so you will interpret data in a particular way, and which a common man like me perhaps won't understand. So how do
So,
you
mhm.
translate that for a common person?
So yeah. So what happens is that when you do any observation, this is like
Mm,
even in our mobile phones. What is
mm,
happening is that we have a pixel, we have camera pixels. In the similar
okay.
manner, all
Mm,
your satellites or all your antennas will have a pixel kind of scenario that will give you your
mm,
number of. So what will your actually reading be from a camera
mm,
is how much
mm.
photons get deposited at a pixel. That's what your
Okay.
camera actually reads. So it's, if you imagine
Okay.
it from a layman's point of view, or a person who does
Mm-hmm.
not know image processing, not a
Mm,
layman, but who is not an expert in image processing. So I'll
mm,
explain it that way. So you
mhm,
can imagine it as a matrix in which a
mm,
matrix, all the entries in that matrix are number of photons
mm.
that you receive on that pixel. Now, that number of
Okay.
photons will be different if I am looking at something. I mean, if it's just an optical image and I'm trying to make out
Mm,
what shape it is making. So, if there's a light
mm,
source, light
mm,
there, the number of photons on that pixel on which the light is falling directly will be more. If there is
mm,
dark or a human is standing, it will judge our
mm,
shape. Now, when the
mm,
light from any object reflects and then it
mm,
goes back on the pixel, it
mm,
makes the facial structure from there, right?
mm,
So
mm.
there are various things that you actually so it's a mathematical matrix that you get of number of photons.
Mm.
That's one example. That's not just the
Okay.
only
Okay.
observation that you do, but that's
Mm.
just one example. So now then you translate those number of photons using different image
Okay.
processing techniques, which involve a lot of mathematical uh, formulations and things, into an image that we see, all the beautiful images that we see. There's an image
Okay.
processing algorithm of a lot of
Mm,
mathematics, functional form, Fourier transforms, Laplace transforms,
mm,
inversions. All these things have gone into it, and then we see
mm,
those images, colored images that we have on screen
mm.
with us. So
Uh,
image processing, lot of mathematics goes. Now once you have your image,
Hmm.
You want to analyze and see what physics it gives out of it. So you need to
Hmm.
actually
Hmm.
put in a lot of modeling, which comes under
Hmm.
mathematical modeling, to
Hmm.
analyze the images and get a sense of what it means for, I mean, in the physical terms, that, for example, for us, how much pollution CO2 is present at a particular location. That will involve a
Hmm.
lot of radiative transfer mathematical modeling to do and calculate that physical number
That.
that we want to give.
So that means it begins with the calculations, and one has to be very precise with those calculations because they form the
Yes.
basis, the path, then you move
Uh,
forward.
yes, as I said in the beginning, satellite or space
Hmm.
technology is one stream which is interdisciplinary. You start
Hmm.
from basic sciences, mathematics, physics,
Hmm.
chemistry, then
Hmm.
you also have all the engineering branches that are involved. So
Hmm.
there is no
Hmm.
escape route for any kind
Hmm.
of technical as well as a basic science line that can be left
Hmm.
behind for when you want to work on any big mission or any big space technology venture. So
Hmm.
it's mandatory. It's mandatory. All the all the
Hmm.
all the streams have to join their hands. There's no way that
Hmm.
you can actually leave
Yeah. You
somebody.
can't work in silos.
Yes, absolutely.
So, just a while back, we were talking about the private sector. Like Indian space sector is opening up to private companies and startups and institutions. Do you think that programs like this ThaparSat can create the next generation of space entrepreneurs? Like how much?
Absolutely, yes.
But like private sector was space was not open to private sector earlier. So, what are
Yes.
your views on that?
Space was not open to private sector earlier. That's a correct statement. But because of like the developments that were happening in our country, now we are at a stage where we call ourselves Atmanirbhar in many of the technologies that we are
Mm,
developing. So now we can happily and proudly claim that we are at
mm,
a stage where we can be indigenous in many space technologies. For example, Skyroot. Let's take an example
mm,
of that. All
mm,
the people who are at key positions in that company
mm,
are very young. Like they are
mm,
in somewhere in their 30s and 30s,
mm,
something like
mm.
that. I can't claim the number 30s, but that's
Mm.
what I
And they're
get
quite
to
young
like.
people. Mm,
Yeah, they're quite young people, and
yeah.
so the point is that that's where our young generation is actually also aspiring. So coming to how
Mm,
these projects like these or the small ventures
mm,
at an academic institute like this helps.
mm,
They first of all they seed the enthusiasm in them that even when they are at young age, they can achieve
mm,
big, and that's something that they need to like believe. If they don't believe in
yeah.
that, they can't do it.
Mm, mm,
Second thing is that when they have a formal training of working on a research project, even if it is a small
mm,
project or a big project
mm,
pertaining to space
mm,
technology, they are already into the loop of reading a lot about it. So it kind of helps them to like be future ready as a workforce also for these companies. One,
mm,
this the bigger
mm,
advantage is now because they have been involved at this stage in our project from a research point of view. So they have started already
mm,
thinking about developing startups based on it. So one
mm,
of the
mm,
person, a group of the students who are working with us already has uh, already is working on a startup from last a few years, which is on image
okay.
processing techniques. So they were working
Mm,
on image processing here, and then that seed went into their mind, and they are already working on a
mm,
startup. They are looking,
mm,
they
mm,
have been incubated at different places. So that's what
mm,
I'm saying. That it's the seed is already being there now. As a
mm,
very natural next step was that we should have we should now start training them in a more formal manner than just research
mm,
projects to a limited group of students. So
mm,
we at
mm,
here in TIT
mm,
we are starting different space related programs also in the academic
okay.
calendars. So we already in this semester, like I said, the basic sciences and engineering, they can't be different
Mm,
and they can't be left behind.
mm,
Any one of it can't be left
mm,
behind if a space technology program has to be developed. So we've already
mm,
started with the BSc majors in space science and astrophysics at the Thapar School of
okay.
Liberal Arts. It
Mm-hmm,
started this very semester, and we
mm-hmm,
are looking forward to some of the very good students who have joined the program already. From starting
mm,
from the next academic calendar, we will be offering a
mm,
minor's specialization in space technology to computer
mm.
science, electronics, and mechanical engineering students. So that way,
And
they will
and
now be, yeah,
and
please.
what's the turnout like? What is the enthusiasm among the students for these courses?
Oh, the house is full.
Okay.
The house is full. I mean, we do get a
Mm,
lot of uh,
mm,
uh, queries, and they have shown their interest and those things. So for
mm,
engineering students, we'll be starting in the next semester. Here also, there are a lot of
mhm,
students who, because I am leading that program, and there are a lot
mm,
of students who always come and ask me. So the house is actually full. So
mm,
it's a good response.
okay.
Yeah,
Okay. And if I may
it's an
ask,
application
how many,
oriented.
pardon me?
Uh, it's an application oriented number, right?
Course.
So it's
Mm,
an application oriented field. So that's where their
mm,
interest uh,
mm.
is. Yeah,
Rather than pure
correct.
academics.
Yes, correct.
Okay. And if I may ask, how many of the students who are into space technology or also those who are working with you are girls?
Oh, quite a good amount of it. The ratio is
Mm.
almost equal. There
One is
is
to one?
the yeah, yeah. So the PhD student, for example, I have who's working on this
Mm.
on these problem is a girl student. And
Acha.
in space technology, I can claim that
Mm.
there is no discrimination. If you look from above, a human is human. So there's nothing
No, no,
like
not discrimination.
no, not discrimination. Okay, pardon my word. I'm
Okay.
just saying that discrimination in the sense that it's equal ratio is participating,
The
and
interest,
that's what.
the, no,
Yes,
I'm
yes,
asking about the
absolutely.
interest of the girl students.
Absolutely. So they're
Ah,
equally interested. They do join good
mm,
projects. The students that we
mm,
send for internships at various industry,
mhm,
we get equal amount
mm.
of applications from both girls and female and male students. And
Okay.
even the majors and minors, they are good. It's the ratio is almost equal. I mean, yeah, that's
Equal.
that's the
Okay.
that's the
Okay.
scenario that we have.
Ah.
Yeah.
And you would be knowing that those Skyroot people, they recently were on KBC, and there that guy said, I think Pavan said, ki we want like the I- Indian government to make the space area more open for private companies, and ISRO should focus on international international level. How much do you agree with that?
Oh, I think if we have to grow, we
Hmm.
have to divide the segments in as a
Okay.
country as a whole. And
Huh.
the way the space program has picked up in last 15 years in India, I think that's a very
Hmm.
positive suggestion. Of course,
Hmm.
ISRO has a lot of experience that is not there with the young players yet. The young
Hmm.
players like us would need hand holding, but
Hmm.
it's a very good suggestion that we can have a division of
Hmm.
the segments that we should be working on, so that the growth rate of the sector is much more.
Hmm.
Because if
Hmm.
we have like segregated already and we are working in a systematic manner, we will grow
mm,
much faster than
mm.
we would otherwise. So it's a very good
And
suggestion by,
and
and actually
and
the
now that
government is working in that direction. I can
mm,
I can claim that the government is working
mm,
in that direction. 2 days
mm,
back only, I saw a post on our honorable Prime Minister's portal and in
mm,
space portal that he actually met
mm,
20 new startups from space sector, and he
mm,
encouraged them to take up the technology development in various phases. So the government is actually
mm,
encouraging and working in
working.
this direction. Yeah.
Mm. And now that your launch date is nearing, how excited are you?
Absolutely thrilled because it has been a roller coaster ride for us and our team.
Mm, mm, mm,
And
mm,
we have been like keeping all our fingers crossed for a successful launch and
mm,
looking from the sky and helping students and the
mm,
community build that part. Absolutely excited and nervous at the same time because it
mm,
has to go. We want. I mean, the launch has to be go smoothly and those things. So,
mm,
and we are trying our best to achieve our goals. So it's
mm,
it's 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 a very different phase that I've like personally seen in my life because I mean,
mm.
how many times you experience your own baby-like satellite going into space in your
Yeah,
lifetime? So that's
yeah.
something that we are absolutely excited about.
Mm.
Yeah.
And as we come to an end of this conversation, one last question. What would you advise a student, a school student, like 17-year-old who's entering into college, who's interested in space sciences? What would be your advice to him or her?
Um, I would like to quote a statement that our VC, Professor Padma Kumar Nair, gives to
Hmm,
always say to us
hmm,
as a closing remark
hmm,
here.
hmm,
He says that always, and that is also there as a tagline of our university,
hmm,
that the possibilities are infinite,
hmm,
and we should be chasing excellence than chasing something that as a materialistic goal. So there are infinite possibilities that a young mind can think of because they are fresh. They can see some of the problems very clearly. They are very clear
hmm,
headed, and so they need to move in the direction of a problem which is of their own interest, and they should pursue it very clearly. So there are infinite possibilities on which they can work, and
hmm,
the rate of their success is extremely high. And the next thing is that they should chase excellence. They should be focusing themselves on being true to the problems they are working on.
hmm,
The if they are true to the problems they are working on, they are giving their 100%. They are doing things diligently. Success will follow. There is no other way, no other option that it will not happen. I mean,
hmm,
everybody is like praising Skyroot's and everybody in space sector praise Elon Musk for his extraordinary achievements that both
hmm,
these people have done. I'm quoting
hmm,
Skyroots all again and again because that's one company who has done a successful orbital launch in their very first attempt. So
hmm,
and they have chased that dream for a long time, but they chase that
hmm,
dream with a objective that we will do everything diligently and
hmm,
in a manner that we will be like thorough in our analysis. So that's something that young mind should take back. They are very
hmm,
thorough, but and they should. keep that spirit with themselves, and
And
the sky is the limit. That's
mm,
the
and be not discouraged with the failures or the setbacks that
yes,
they encounter.
absolutely.
Mm.
In any kind of venture, uh, I always tell my students that
Mm.
negative result is also a result, right?
True.
It's a result.
Right.
It's an
Mm.
output that you have got.
Mm.
You
Mm.
did something, it didn't work. So now you know that this is something that does not work. Now I have to look
Mm.
beyond this. Even a
Mm.
negation is a result.
True.
Behind an Einstein, there were
Mm.
100 non-Einsteins. Behind an every successful experiment, you will fail. You are
Mm.
bound to fail. But
Mm.
the failure, for example, in
Mm.
space technology, for example, in any space sector, we do a lot of
Mm.
tests for any instrument. So you
Mm.
should be, that's what I said. I mean, you should be thorough and diligent in the process, because while you are
Mm.
in the process, your experiments will fail. You will learn. You will evolve, and you will achieve.
Mm.
So the failure is at the experimental stage. But you know, when you
Mm.
have set your goal, the ultimate goal
Mm.
will be achieved. So that way, I
Mm.
mean, it's a win-win situation. That's a part and parcel of all everybody's life. I mean, starting
Mm.
from getting up in the morning to sleeping in the night, we do see a lot of things
Mm.
happening around us which don't work on the first
Mm.
place. So
Yeah.
but we don't leave it, right? Yeah, so that's
Yeah.
something that everybody has to take into consideration.
Yeah. Yeah. So thank you so much, Dr. Gulati, for talking to me. And I wish you all the best for your successful launch. And
Thank you
I
very
also
much.
wish you that maybe after this launch is over, you begin work on the next one.
Absolutely, we are looking forward to other projects
Mm.
that are there in pipeline in
Mm.
Thapar. I'll
Okay.
suggest the audience to keep looking at the
Huh.
space, and
Yeah.
we have a lot of exciting ventures that will come up in future. Uh,
Yeah.
with
Yeah.
us. And thank you so much for inviting us. It's a
Yeah.
pleasure
Thanks. Yeah.
talking. It was a pleasure talking to you. And
Mm.
one message to my students that
Mm.
follow the 3D mantra for success: dedication, devotion, and determination.
Mm.
If you have like if you that's my mantra. I
Mm.
can say that it worked for me, and I
Mm.
wish all the best to the students in future who are watching this podcast, that
Yeah.
it should
Yeah.
work for it may work for them also. So thank you so
Yeah.
much
It
for
will definitely work,
inviting me.
not just
Yeah,
for the students, but for everyone who's listening to it, the
absolutely,
3D mantras.
absolutely.
Yeah. So
Yeah,
thanks, Dr. Gulati, once again. And I wish you all the
thank you so
best.
much. Thank you so much.